Welcome back, guys, to the Cyber Advent 2024 day 19. Today we're going to be doing some fun stuff. We're going to be doing some game hacking. So pretty much while we're playing the game, we're going to be hacking it. I guess you could say that. But we're going to learn, how you would actually go about doing this. A little bit about executables, a little bit about libraries, and then the tool we're actually using today is going to be called Frida. Let's go ahead and get this story going. Oh, by the way, I'm Aaron, aka Cyber Sensei. Welcome to the channel if you're new here. I'm going through this series, and then after that, we'll be posting some other regular videos. So, Glitch was keen on uncovering Mayor Malware's deeds. Today he was sure he would find something neat. He knew the mayor had an office downtown where he kept his dirty laundry. The big old clown. He approached the site silently, not knowing the door was closed. So ultimately, at the front of the door, a smart lock awaited. Glitch smiled, cause he knew it could be subverted. But oh, big surprise, the lock was eerie. A game controlled it. Glitch almost went teary. If you are wondering how this came to be, Mayor Malware himself will explain it quickly. Technology gets broken every day, was his claim. But nobody knows how to hack a game. Will Glitch be able to pass through this door, or will he end up with 0 as his score? Yeah, there you have it. We're going to be hacking Mayor Malware's game today. Learning objectives are understanding how to interact with an executable API, intercept and modify internal APIs using Frida, and then we're going to hack the game with the help of Frida. This first part here is a little bit more like theory and explaining these concepts a little bit before we actually dive into like the hands-on portion. But go ahead and start up your machine. We only need the machine from this room today, so you just come here, hit start machine, and then while that's loading, we'll walk through this together. Believe it or not, game hacking is a really small portion of the hacking scene and malicious actors. Most people focus more on stealing data, exfiltrating data from companies just because that's worth more than just hacking a game. And also due to the fact that it requires a lot of different skills. Like here you can see it says memory management, reverse engineering, and networking knowledge if the game runs online. And every game nowadays, if you play the new Call of Duty or even single player games, are requiring you to be connected online in order to even play the game. So everything to a degree has now networking in it, so that just adds a layer of complexity to being able to hack the game. But let's move on. So executables and libraries. So the main difference here, an executable is the actual application that compiles and runs at runtime, and then a library is where a bunch of functions are stored that the executable is going to be using throughout its running process. And they give us a little example here, right? For instance, this game executable is wanting to do some addition using the add function here. It gives two inputs, X and Y. So the actual game executable isn't going to hold this function right here. This function is actually in libmaths. So this is the library. And so what it's going to do is, let's just say, you're playing the game, it asks for two numbers, right? So let's say you just you input 2 and 2 on your keyboard. Game executable is going to reach out, calling this function, put 2 and X, 2 or Y is. It's going to go in here. This thing is going to do the maths, and then it's going to return you 4 back to the game executable, and then the game executable will proceed with that answer. Where the vulnerability lies here is executables are implicitly trusting libraries to do everything the right way. For example, if the game executable needs to do math, it'll send over this, call this function, send over 2 inputs, and then it'll get the response normally, right? It's the normal flow. But if we were using Frida, what we could do is actually go in and intercept this call and change these values. So instead of 2 and 2, we could put 4 and 4, right? And then now when the sum comes back, it's now 8 instead of the real output, which should be 4. So that's essentially what we're doing today, right? We're going to be intercepting, understanding what functions are being called when certain actions are being taken in the game, and then we're going to actually go ahead and manipulate these functions to do what we want it to do, so that way we can hack the game and pretty much save the day. So let's go ahead and keep going. So here they're going to introduce how hacking with Frida works. So yeah, this is pretty much what I just described. It's a man-in-the-middle scenario. Kind of like if you think back to the previous days using Burp Suite and how we're catching the requests, modifying them, and then sending them with a different input. This is the same exact thing, but with executables and libraries. So we're going to be here in the middle. We're going to be catching all the requests that the executable makes to the library, and then we're going to be modifying it with our desired inputs so that we get our desired output, and that way we're going to be effectively hacking the game. So they give us an example here of what this would look like in real time. So here's an example. They run this program which just displays hello and 1. And then what we do is we run Frida trace, right? And what this is going to do is it's going to create listeners or handlers for when this actually runs. If we do this command right here, what's going to happen is now we're going to see through the command line and through Frida what functions are being called when this is taking place, right? Specifically, you will now see the handlers directory containing JavaScript files for each function of the application calls from a library. One such function will be called say hello. So that's the function that's running this right here. And the handler will be at this path right here in the Frida library. All right, so they're explaining how the function works, say hello here. So each handler has 2 functions known as hooks before and after the function call. So the onEnter is the one we're mainly interested in here, and it has the args variable, an array of pointers to the parameters used by our target function, and onLeave is the return value. I'm pretty sure that's what that's short for, variable which will contain a pointer to the variable returned. You can see that right here. So args and retval are the ones that we want to modify. So what we're going to do is we want to set the parameter to 1337, and we're going to replace the first argument in this array here, which, if we recall, here is an array of pointers. So what we're doing is we're modifying the first pointer in this argument, and we're going to make it contain this value right here, 1337. I know this is going a little bit in depth for people that are new or don't have that much coding experience, but I'm trying to make it as simple and straightforward to understand. So Frida has a function called ptr that allocates some space for a variable and returns its pointer. So we also want to log the value of the original argument, and we have to use the function toInt32, which reads the value of that pointer. So pretty much what we have to do is, in order to assign 1337 to the first pointer in this array, we have to first assign some memory for this variable, and then we have to actually convert it from the type, and then what we're doing is making sure that it's read as an integer in this memory that we've allocated. This is what that would look like if you wrote it in code. So here we're calling it original argument, which is arg0.toInt32. So what we're doing is we're getting the original argument, like the original pointer that's in this location, and we're converting it to an integer so that we can see what it's displaying, right? And then we're going to print that out to the command line, is what this says. We're going to print this original argument value, whatever it is, out to the command line, and then we're going to replace here this value with 1337, and then we're going to call the function again. We're going to log it here. So here we can see the output of what we did here, and you can see we're now displaying 1337 where the 1 used to be, and we're still displaying the original argument that it was before we intercepted and changed it using Frida. So that's what all this code does essentially. And if you want to understand like more exactly in depth about what this code does, I recommend you copy this and put it into ChatGPT and just say, explain every line of this code and why this works. That way it'll give you more comprehensive walkthrough of what the whole code and line by line, and that way you get a better understanding. Moving on. By now our machine should be up and running. You can do show split view, and then you want to hit wide view if you want to have yours full screen like I do. I'm going to move this over here, but let's go. So we're going to go over to this directory here, and then we're going to run the game so you can see what we're hacking today. Desktop, try unlock me, then we'll ls, and then we can just run that. So that's how we would run it, and we get the game here. So plus space, This is how we move around. Space. So this is the game right here. So we go over here. Can't do anything. Go to this penguin guy. Welcome to TryHackMe. The only game-based lock in the world. A game. Aren't smart locks good enough? The mayor fears any lock that's smarter than him. Want to know how it works? Nice. Let me explain it to you. So to open a door, we need to prove we're mayor malware via our 3-factor authentication system. Crazy, bro. You guys are revolutionary. Something you know, something you own, and something you are. Okay. The first factor is that random number thingy the mayor has. You mean one-time password? Yeah. Oh yes, the mayor mentioned something about that. The frostbitten one-time password. Do you have it? Obviously we don't have it. Wrong number. You don't compare malware to me. Alright, so first order of business, we need to see how we can intercept the one-time password and see if we can actually get the function to display it to us. So what we're going to do is we're going to close this game out, come back over here, and we're actually going to run Frida now so that we could actually see what's going on when we play the game. So let's go ahead and do that. Come over here. That's not what I wanted to do. Place in clipboard. And then we'll paste that in there. So this is the command we're running right now. So just to break down a little bit, we're running Frida traces the command. We're inputting the TryHackMe executable as the thing we want Frida trace to basically create handlers on. And then we're inputting the specific library that we want to be tracing. So that is how this command's working essentially. Let's go ahead and run it. Boom, there you go. And we can see we get some stuff here. So now what we have to do in order for us to understand like what function we're trying to manipulate here, we got to go and see what function is called when they try to check the input we give for the one-time password. So let's go ahead, skip through all this, and then we'll just enter 1, 2, 3, 4. Boom, wrong number. And then we'll come back over here and we can see now that this is the function that's being called to check the one-time password. So this is the one we have to go in, analyze, modify, and then that way we can actually get the one-time password and proceed to the next stage. So we'll go back over here, and they want us to do this in different terminals. So here what we're gonna do is we're gonna open up this library, right, that we've just generated by tracing the functions in this game. So we've done that. I'm going to paste, and all we're doing in this command is just changing directory over to where the handler is actually at for Frida. So if we ls, we can see, so we can just open all of them using the code. And that's how we would do it. We're opening this whole directory in the code app. Okay, there we go. Yeah, Visual Studio Code. This is gonna make our life easier because IDEs are fun. And we're gonna click on this one right here. So let's go back over here. We can see the function which we saw, and then the I at the end of set OTP function indicates that an integer will be passed as a parameter. It will likely set the one-time password by passing it as the first argument. So to get the parameter value, you can use the log function, specifying the first elements of the array args on the onEnter function. So, it looks similar to what we did earlier, right? So what we're doing is we're printing it out to the command line using the log function. And what we're doing is we're changing this into an integer to see exactly what it is. Instead of getting the pointer memory address, we want it to be the actual value that it's holding. So that's what the .2int32 does. So let's go ahead and edit our file. So we'll just add that in. Right there. Boom. And we'll just save that. We are all set. Let's go ahead and put this over here. So many things on the screen. But let's see if it works. I don't know if we have to restart, so I'll just try without. Okay, it worked. So you can see over here, it's now printing out the parameter that it's checking for. So if we put that in, hopefully we will get the pass. So boom, we've done it. We've hacked the first part of this game. You can see the flag down here. Go ahead and note that down for later. But we've done the thing. So now we can come over here. And this guy is now gone. So we can go to the next part of the game. Got a computer. Got another blocker over there. And let's go to this penguin. We'll just go ahead and talk to him. You are now verified to be at least 1/3 of malware. Congrats. A second authentication factor is called a wish list for billionaires. Sounds shady. How does that even work? I'd be silly to tell you that could compromise the whole system. Oh, at least you're more security aware than the last guy. Am I? Alright. I'll explain it just this once because I like you. Malware is the only one in Wareville with a super ultra mega premium extra hyper plus card plan. Bro is ballin', dude. This means he is the only one who could buy the coveted flag 2 item from the store. Does he pay 1,000,000 coins every time he needs to open his door? He does, but then he refunds the product. I should be rich by now, if not for cheap bear. Poor guy, bro. But hey, if you are having cash issues, you can always mine some coins from that old PC. Is there anything you want to buy now? Let's see. We only have 1 coin. But yeah, so let's get some advice. And we did get the function over here. So let's see. You don't have enough money. Use the PC to get more coins. Okay, so if we just hit space a bunch of times, we get money. But obviously, we want to be efficient and not sit here and click this, 900 and 1,000 times, So let's just see what happens if we actually are able to buy something. It's still the same function. A narrow focus brings a big result or something. I think we just got robbed for that advice we just bought, but hey, who's counting? Alright, so we've got our function there. So I'm going to come back over to the code. And it's validate purchase I. So if we remember, the I from this function, the OTPI, said it was integer. So this one with 3 I's, I'm assuming is going to be 3 integers. Very similar structure to the last one. And what we'll do is we'll go back over to here. And yeah, we can see the function buy item is displayed as validate purchase I. 3-letter I after its name to indicate that it has 3 integer parameters. Boom, I'm just a genius. I don't know how else to explain it. So we're going to do exactly what we did in the last one, and we're going to print out all the values that it's receiving from the game executable to see what exactly it's printing out, and that way we can decide how we want to manipulate it going forward. So we'll go ahead and do that. We're just going to copy those 3 lines, put it in the clipboard, and then come over here and paste it in. And I'm gonna fix this because white space matters. Sorry, colored space to be politically correct. But yeah, so we're gonna save that. Boom, we're good to go. Moves back over here, get the game back up. And we're gonna go ahead and see what gets printed out when we actually try to buy something. So we'll put a 1 in there, and we'll do a 3. Hit that. Boom. All right, so 3. All right, so the integers that we got, it's pretty easy to tell what they're associated to. So 3 is going to be the item that we're actually buying. This number is going to be the price of the item that we're buying, and the third number is going to be our wallet amount. So we have to find out a way to edit the third integer so that it is what the amount we want it to be. So let's go over here. So yeah, we can see the third is the player's coins. If you manipulate the price and set it as 0, you can buy an item, any item you want. So they actually have a different approach. They're just going to put the price of everything to 0. That way our wallet is always going to be enough. And how we do that is through this. So again, simple, we're assigning. So let's go to the whiteboard here. All right, so an array is going to have multiple items in it, right? So X, 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 for example, right? And now you would think you would start by counting 1, 2, 3, but in computer programming and computers, they do things correctly, unlike us, and they start at 0. And this is called an index. So an index just means the location in the array of the value that you're looking at, right? So the indexes would go like this, as follows. Always starts from 0 in programming. So when we're modifying the second value in the array, the index is actually 1. So that's why if we come back here, we're modifying args1 to be 0, right? That's how you can see it. So we're modifying the second argument in this array, which is going to be the price of the item we're trying to buy, and we're setting it to 0. So let's go ahead and do that. We're going to go to the buy item. So let's go back to our code over here. But actually what I'm going to do is change this to be what we need to type out. So it's going to be arg1 is equal to ptr 0. Semicolon. Oh, because the variable's wrong here. So make sure you spell your variables correctly. So we'll go ahead and do that again. And boom, there you go. So we've got the second flag here. Make sure to copy this down. Make sure you notate it for later. And you can see here the the third parameter is now 0. We didn't log the one that we edited, but if we did log it, it would say 0 as well, and then it would be okay, 0 is equal to 0, so it works. This guy can buy this. So boom, we've done the thing. Let's move to the third section. And let's explore this. All right, so nothing too cool going on here. We'll just talk to this guy. Just one more factor to overcome to fully become mere malware. The last authentication factor is biometrics. At last, a normal authentication factor. So whose eyes do I need? Eyes? This is a punch-based authentication system. Mere malware has a very specific way of punching the keyboard that nobody can replicate. And here we go again with the madness. Should I punch my keyboard then? Well, you can gently put your hand on the keyboard. No need to get violent. I was worried for a second. Now show me the keyboard. Please put your fist in the keyboard. Naughty fingers, I see. Are you sure you are mere malware? Alright, so after talking to Mr. Pinguino, we get our function that we need to look at. And we can see the ditch after our PKC, right? So I'm going to assume here this PK means private key. So we're going to go to biometrics here. So we'll go back over here, follow along. Oh, so this one's handling strings, so it's a bit more complex to debug. So we found this function. This one's dealing with strings, not integers anymore. And you can add the following code to the onEnter function, but we're going to be using this argument here versus the dot 2 and 32 because it is a string. This is the parameter we're going to see displayed, and it's not very helpful. So what we can do is log the return value of the function by adding the following log instructions to the onLeave function. I understand what's happening. So we'll go ahead and look at the code here. So first of all, we're going to change this to memory dot read C string. Then we'll put this in there. Args 0. Put a second parentheses there to make sure everything is nice and dandy. And then in the onLeave function, we want to have the log retval plus retval, and then save that. And we'll go back to the game over here, see what we got. Alright, so we've got an error on our memory thing, but I'll fix that in a second. But we can see the return value is 0, right? So it's safe to assume that what this return value is saying is 0 is going to be, if you think back to booleans, and booleans are just like true or false in programming language, we just call it that. But anyways, a boolean is either true or false, right? Either a 0, false, or 1, true. And in this case, we're getting a 0, which means false, right? So the check did not pass, we did not validate anything that this guy was trying to validate, and he knows we're not mere malware. So what we want to do is return a value of 1, and we can do that using our Frida to make sure that we just bypass this check entirely and the function just always returns 1. So that's what we're going to do. One sec. That's why it wasn't all caps. But yeah, now that should work. So then all we're going to do here is we're going to do retval.replace, and we're going to do ptr1. So we're assigning 1 to retval so that when it returns on the onLeave function, we get a 1 instead of a 0, therefore passing the penguin's check. So let's actually see if we successfully get that. It says, that's weird. You didn't punch the keyboard, yet the signature is correct. Mere malware would have hit it with all his might. Who are you, imposter? You can't fool me. Me? I'm the mayor. Yeah, I'm the mayor of malware. Vote for me, please. Oh, my bad. Welcome, mayor. We missed you. He needs to get better penguins. Boom, there you go. Don't smash your keyboard is the final flag. And we've successfully hacked through Mere Malware's game security. And we've accomplished the thing. We've accomplished the access to all his secrets. So that's it for today, guys, in terms of the hands-on portion. What we'll do is, you just come down here, make sure you paste all the flags in here to get your correct answers. The first one, we hacked the guy, the penguin, looking for the one-time password. The second one, we manipulated the vendor to get our flag for free. And 3, we didn't punch our keyboard and we passed in our verification correctly. So the penguin, he was a little suspicious, but we were able to use our powers of persuasion to make him believe that we were Mere Malware. And then over here, they do have, if you liked the today, which I personally really liked today, the game hacking, because this was something new for me. So it was really cool to experience, how actually game hacking works. I mean, this is a very simple, example of what game hacking is. I'm sure it's way more complicated in the real world for like big games and stuff like that. But either way, it was a super interesting day. They have another one in Advent of Cyber 2023, so go check that out if you're interested. To recap, guys, we've hacked the game, and we have bypassed all the security measures that malware has put into this game. And how we did it was using Frida to intercept all the requests that the executable was making to the library to process the validation checks that were needed for each stage in the game. We did have to do some coding today, which if you're new to coding, congratulations, you've now coded for the first time in your life. If you've done coding before, now you understand how to hack some games. But yeah, overall pretty cool game. I appreciate you guys stopping by. If you guys liked the video, drop a like. If you want to follow along, leave a subscribe. Share this with a friend you think would get some knowledge out of this. But yeah, it's been real, guys. Cyber Sensei Aaron out. Peace.